Hello everyone, for this tutorial video, I'd like to explain how you can solve integrals involving quadratic formulas, which is the last method of computing integrals. In particular, if we are given this integral, we may not think we can condense it right away. But if we are creative about this, we see that if there are 4 instead of a 5 on the last term, we could condense this as x plus 2 squared. So in conclusion, we can rewrite this as x plus 2 squared, with the caveat of adding 1 for the 5. We next do substitution in terms of angle to get rid of the square root by doing x plus 2 equals tangent of angle. So we have tangent squared plus 1 equals secant squared, and square root of secant squared is absolute value of secant. But since we are doing an indefinite integral, we can forget the absolute value bars. And we see the change in x must be, after we rewrite x in terms of tangent of angle, secant squared of angle times change in angle. So in conclusion, the integral of secant times secant squared times change in angle is the integral of secant cubed with reference to change in angle. We compute this integral and see that the secant of the angle must be the quadratic equation over 1, which is simply the quadratic equation we had in the original integral. So we plug this in for the secant, and we plug in what we found for the tangent earlier, to get everything in terms of x rather than degree, and this is our final answer. Now that we have figured out integrals involving quadratic equations, we can discuss a special type of definite integral called improper integrals next. Don't forget to subscribe if you found this video informative, and make sure to see other tutorial videos, and follow me on either Facebook or Twitter for more content.